Hey, welcome to The Explainer. All around us right now, there's this vast, unseen network of tiny digital sensors, and they're quietly listening to our planet. Today, we're going to explore how this network is literally giving our environment a voice and what it's trying to tell us.
So let's start with a crazy question. What if a river could tell you it was getting polluted? Or what if a forest could scream for help the second a fire started? I know, it sounds like something straight out of science fiction, but this idea is at the very heart of one of the most powerful technologies at work today. And this isn't some far-off future idea. This talking world is being built as we speak. It's not magic. It's a technology you've probably heard of called the Internet of Things, or IoT for short. And it's completely changing how we interact with the physical world. Okay, so what exactly is the Internet of Things? Well, to put it simply, it's all about taking everyday objects, embedding them with tiny sensors and little computer brains, and then hooking them up to the internet. This lets them collect and share data, and that's how we start to create a really smart, responsive environment. Now, this might all sound super complicated, but here's the secret. Almost every single environmental IoT system follows the same simple, repeatable framework. I kind of like to think of it as a recipe. And here it is. It's a really straightforward four-step recipe. First, you have to sense the environment to gather that raw data. Then, you need to process that data to make sense of it all. Third, you connect to the internet to send that information somewhere useful. And finally, you inform a person, usually by displaying it on an app or a dashboard. Sense, process, connect, inform. We're going to see this pattern again and again. And this is where that recipe becomes real hardware. So for the sense step, you might use a temperature sensor, like a DHT11. To process it, you'd use a tiny computer called an ESP32 microcontroller. That's what analyzes the readings. The connect part? That's handled by a Wi-Fi or a cellular module. And the inform step happens right on your phone, through an app or a cloud platform like ThingSpeak. These are the actual building blocks for this stuff. So let's see this recipe in action, right? Let's take a little world tour, and we'll start with one of our most precious resources, water. First up, let's look at a high-tech fish farm, what they call aquaculture. Now, the challenge here is absolutely huge. The health of thousands of fish depends on keeping those water conditions perfect, 24/7. Even one small change can be a total disaster. So how do they apply our recipe? Well, step one, sense. The system uses a whole team of different sensors. You got a pH sensor checking acidity, a dissolved oxygen sensor, a turbidity sensor for water clarity, and a bunch more. Think of them as the digital eyes and ears constantly watching the water. And this is a brilliant example of that final inform step. All that data gets processed and sent right to the farmers' phones. So if a critical level, like oxygen, suddenly drops, they get an instant alert. And check this out. The apps are in their native languages. That's what makes the technology truly accessible and actually useful in the real world. And this recipe isn't just for water. Let's think about something like fuel storage. The challenges here are things like preventing theft, watching for leaks, and just making sure the fuel quality stays good. The components here follow the exact same pattern. You sense with flow meters and level sensors, you process the data with a microcontroller, and then you connect using a GSM module that can send a text alert if, say, the fuel level suddenly drops. It's so simple, but it's incredibly effective. All right, now let's move from water to land and see how this very same recipe helps us build smarter farms and forests. Okay, for farmers, the big challenge has always been water. If you use too little, the crops die. If you use too much, you're just wasting a precious resource, not to mention money. The goal here is all about precision. So once again, the IoT recipe comes into play. You've got sensors measuring exactly how thirsty the soil is. But here's where the inform step gets even smarter. Instead of just sending an alert to a person, intelligent controllers actually act on the information automatically, opening valves and controlling pumps to deliver the absolute perfect amount of water. Now let's talk about a problem where every single second counts, detecting wildfires. Out in these huge remote forests, a tiny spark can turn into a raging inferno before anyone even knows it's there. The solution here is a whole network of solar-powered sensor nodes spread throughout the forest. They sense for things like smoke and sudden spikes in temperature, while also logging other environmental data.
As soon as a sensor triggers, it uses long-range wireless to blast out an alert that goes to a central server and right to a smartphone app, pinpointing the fire's exact location on a map for the firefighters.
So, we've seen all these examples, from fish farms to forests. What's the big picture here? Why does building this huge, invisible network of sensors actually matter so much?
This slide really gets to the heart of it. We are moving away from the old way of doing things, sending someone out for periodic manual checks, which always means slow reaction times. We're moving to this new IoT-powered way where we have constant, real-time data and instant alerts. But the really crucial shift here is this. We're going from being reactive to being proactive.
And that's really the ultimate takeaway. We are fundamentally changing our relationship with the environment. We're moving from a world where we basically had to guess what was happening to a world where we know. We're going from just reacting to problems to actively predicting and even preventing them. That is the real power of this technology.
Which leaves us with a pretty fascinating final thought. For the very first time, we've built a system that lets our planet talk to us, to tell us what it needs, directly and in real time. So, now that it can talk, the only question left is, what are we going to ask it next?